The directions say use the figure to find the exact value of each trig function. So I'm going to flip back over here to my formulas because I see that I've got the double angle formulas on page 387. So let's look at I'm going to look at page 387. I have a formula for cosine 2 theta, and it is, well, I have a bunch of different ones. Let's do y'all have a preference on, if you look on page 387, you get cosine squared u minus sine squared u, or 2 cosine squared u minus 1, or 1 minus 2 sine squared u. I want one that just has one trig function in it. I'm going to pick just randomly 2 cosine squared u minus 1. And the reason I'm picking it is because I just want one where I have to find just the cosine and not both the sine and the cosine. I'd have to find both the sine and the cosine if I picked the top formula. Could have picked the other one, it would have been just as easy. All right. Now, if we had done A and B, we would have had the values that we need. What is the cosine? What is the cosine of this angle? I guess I should have called it U. 4/5, right? So we can just stick that in there. This is an easy one. We don't have to go use any square formulas or anything, even though we have some in this section. So all we have to do to evaluate this is say, okay, square 4/5, that's what, 16 over 25? And then subtract 1, so that's 32 over 25. Minus 1, I'm going to write that as 25 over 25, just so I have it with a common denominator, right? Just plop that in there. And wouldn't that be, what, 7 over 25? 32 minus 25, I believe, is 7. We need the 7th graders to help us with our mental math. They'd be popping this stuff out real fast. I'm going, Okay, so C wasn't too bad. We just picked a formula, and if you want to make it easier on yourself, pick one that just has the cosine in it, or just the sine, so you don't have to figure 2 of them out, even though you'd have them if we had done A and B. All right, D, sine 2 theta. We don't get choices on this one. It's 2 sine theta. I'll just use theta since that's what we have here. 2 sine theta cosine theta. Well, we just said that cosine theta was, what, 4/5? We found that one on the C part right here, right? What's the sine of this angle? 3/5. So that's going to be 2 times 12 over 25, which is, what, 24 over 25? So that's not too bad, is it? If we look at we only get one formula for that, so we don't have any choices here. 2 times the tangent of theta divided by 1 minus tangent squared theta. Okay. So really all we got to do is find the tangent here. Okay, so if our angle is here, tangent would be opposite over adjacent, right? So 3/4, we agree? Okay. So that would be 2 times 3/4 over 1 minus 3/4, plugging it in again, and then we got to square it. I'm going to reduce on the top. That'd be, what, 1 and 2 there. So wouldn't I get 3/2 on the top just by reducing that fraction? On the bottom, I'm getting 1 minus 9/16. What's 1 minus 9 over 16? We could rewrite 1 as 16 over 16. What is it? 7 over 16. Yeah, 7. So it would be 7 over 16. Because we could rewrite this as 16 over 16. And just subtract. So if you remember, when we got a complex fraction, we take the numerator and we multiply by the reciprocal, or the flipped fraction of the denominator. And I'm going to reduce first because I don't want to have to reduce later. 2 goes into 2 once. And wouldn't that be 8? So on top, 3 times 8 is 24. And on the bottom, 1 times 7 is 7. And that would be our answer. It would have helped if I had turned it on, but we're talking about how to put this in the calculator. You put it on y1 equal, and you go to second trace, and then you pick the one that has 0 on it. And then you hit left, enter. You put your cursor to the left of 0, hit enter. You put your cursor to the right of 0, hit enter. And then it'll say guess, I think, and you hit enter again. And it'll show you the value x1 equal, y1 equal your x-intercepts are going to be this x part of it there. So that's how you do it in the calculator. I guess we'll stop this now since it's time for you guys to go.